All right, our next topic is power, which is really not that much. It's a pretty easy step from what we were talking about with work and energy. First of all, let's talk about what is power. Power is just the rate of energy transfer. So how quickly energy is changed from one thing to something else, either a different type of energy or transferred from one object to another object. We can also think about this as how fast work is done, because we know work and energy are not exactly, but they're almost kind of the same thing, same idea. They're very related. And so let's make an equation here. So power, we're going to use a capital P, and I know we used lowercase p for momentum, but try to keep them straight. I don't think we'll have any problems where we have power and momentum in the same question, so that should be, shouldn't be too bad. Anyways, power is how fast work is done. So basically, how much work are we doing in how much time, which we could write as W divided by delta T. Sorry, this little thing keeps popping up. I'm going to try to keep my mouse away from that. So W for work divided by delta T for change in time, how much work is done and how much time. We could also think, though, that work, we know, is force times distance, or force times delta x, which is, that's a definition for work. And so I can plug that in and then divide by delta T again. There's another equation for power. But then we might also notice that delta x divided by delta T is the same thing as velocity. So I could rewrite this again as force times velocity, which would be a pretty nice little equation there. So those are our main equations. I think the most useful ones out of that are going to be the first one I gave you and the last one, although the second one in there in the middle might come in handy too. But before we use any of them, let's just go through and look at some, make sure we know what all these variables stand for. So the P is for power, obviously. Capital W, we just said, was work. Delta T is change in time. F is force, and V is velocity. So that's all those variable definitions. Let's also make sure we know what units we're going to use for each one. So for power, I'm just going to tell you we're going to use the watt. James Watt was a scientist who studied this, and so we kind of call it a watt in his honor. We use a capital W as the abbreviation for that unit, and this gets confusing because I just also said that capital W was used for work. So my apologies. I didn't make up the rules. I know it's kind of confusing. My tip for you is that if you see a W in an equation like this, we're talking about work. If you see a number with a capital W after it, we're talking about watts. So good luck. I believe in you, but that can be confusing. Okay, so anyways, moving on. The unit for work is not the watt. The unit for work is the joule, and we use a J for that. Unit for change in time is seconds. We just use a lowercase s for that. Unit for force is named after another scientist, the Newton. We use an N for that. I should also mention that Joule was a scientist. I forget the first name, but anyways, that's named after another scientist. And then velocity, our unit is going to be meters per second, and we abbreviate that with an M divided by S. Okay, so this kind of helps us, looking at these, this kind of helps us think about the watt also. Okay, so we know power is watts. That means we know that this has to also come out to watts, but we can kind of break it down and see that, okay, work, we're going to measure in joules, and time we measure in seconds. So another way we could think about a watt is a joule per second, and that makes sense. That's how much energy in how much time. The third way we can think about watts are, remember, force we're going to measure in newtons, and velocity we measure in meters per second, and so we can think of a watt as a newton meter divided by second. In fact, we could probably break this down even more because we know a newton is a kilogram meter per second squared. And so we could have kilograms meters squared per second cubed would also be a watt, but that's probably not going to be very helpful. So what is a watt? So really, it's just how much energy is used per second. And there are a couple ways that we might be familiar with watts. So the first one is if you look on the top of a light bulb, sometimes you'll see a little 60W or a 40W or a 100W up there. That's just telling you how much energy that light bulb is using per second. And the higher the number, the more energy it's using. Another place you might see it is in a speaker system. So, again, the higher the number, the more energy, the more electrical energy that stereo system can convert to sound. So the bigger the number, the more powerful or the louder those speakers are going to be. The last place has to do with this little 745.7 watts equals 1 HP or 1 horsepower. And so we use that to measure how powerful engines are, engines in cars or trucks or school buses or whatever. So that's another way that you might be familiar with the concept of power.